Now in this video, we're going to take up one more problem on the shaft. The problem reads as problem number 26. A shaft of diameter 30 mm is subjected to torques as shown in the figure. Find the maximum shear stress and the angular deformation of D with respect to A. G will be equal to 85 GPa. So you have a uniform diameter of 30 mm, having length of AB is 2 meters and length of BC is 1.2 meters and length of CD is 1.5 meters, having the torque of counterclockwise direction of 250 Newton meter at TAB. At TBC, you have clockwise 200 Newton meter, and TCD will be having counterclockwise, which is 125 Newton meter. So here we have the torque diagram. As we see between the torque CD, we have the counterclockwise direction is negative. So you're going to get 125 Newton meter negative. At torque on BC at the cross section, which is at this BC, you will going to have the torque as minus 125 plus 200, which becomes 75 Newton meter. And torque at CD, again, it is minus 250. So plus 75 minus 250 will be equal to minus 175 Newton meter. So this is how you will be able to plot this torque diagram. So once you do that, so G will be equal to 85 GPa, which is 85 into 10 to the power of 3 Newton per mm square. So DAB will be equal to, as the diameter is uniform throughout the cross section, DAB, DBC and DCD will be equal to D, which will be equal to 30 mm. So length of EB is 2 meters, so 2000 mm. The length of BC is 1.2 meters, it is 1200 mm. And length of CD will be equal to 1.5, which will be equal to 1500 mm. TCD will be equal to 125 Newton meter, which is 125 into 10 to the power of 3 Newton mm. So which is counterclockwise, and theta BC will be equal to minus 125 plus 200. So you're going to get 75 into 10 to the power of 3 Newton mm. Since it is positive, it is clockwise. So we are taking the clockwise moment as torque as positive and counterclockwise as negative. So similarly, TCD or TAB will be equal to minus 125 plus 200 plus minus 250. It will be equal to minus 175 Newton meter. So that is minus 175 into 10 to the power of 3 Newton mm in counterclockwise direction. Now we are going to find out the maximum shear stress. So shear stress tau will be equal to T by Zp, where TR will be equal to tau into Zp. As the diameter is same for all the sections, so shear stress is directly proportional to the torque. As the torque is maximum at the segment AB, the shear stress will also be maximum at segment AB. So maximum shear stress tau max will be equal to TAB by ZAP, which will be ZAP is the polar section modulus at segment AB. So which is JAB by R, which will be equal to pi d to the power of 4 by 32 divided by d by 2, which is pi d cube by 16, which will be equal to pi into 30 cube by 16, which will be equal to 5.3 into 10 to the power of 3 mm cube. So therefore, the maximum shear stress will be equal to 175 into 10 to the power of 3 divided by 5.3 into 10 to the power of 3, which will be equal to 33 Newton per mm square. So similarly, angle of deformation D with respect to A, theta D by A will be equal to theta D of A will be theta D of C plus theta C of B minus theta of B by A. So that will be equal to minus TDC into length of DC by G into J plus TCB into length of CB by G into J minus TBA into length of BA divided by G into J. So taking the common factor, 1 divided by G into J into minus TDC into length of DC plus TCB into length of CB plus minus TBA into length of BA. As DAB equals DBC equals DCD equals 30 mm. So we have, which will be equal to 1 by 85 into 10 to the power of 3 into pi by 32 into 30 to the power of 4. Open the bracket. Then it is minus 125 into 10 to the power of 3 into 1500 plus 75 into 10 to the power of 3 into 1200 minus 175 into 10 to the power of 3 into 2000. On simplification, you will going to get it as minus 0.0662 radians. So convert this into degrees. That will be equal to minus 0.0662 into 180 by pi, which will be minus 3.8 degrees. Therefore, the total angle of twist theta or theta of D to A will be equal to 3.8 degrees counterclockwise direction. So tau max will be equal to 33 Newton per mm square, and theta or theta D by A will be equal to 3.8 degrees counterclockwise direction. So this is how you will be able to analyze and solve this particular problem. Thank you.